Welcome back. Welcome back. Here we are. Part two of the discussion today. We just talked about seasons and what causes the seasons, right? The raisin days. All right. So now we're going to talk about there's different factors that affect the climate of a region, right? And the reason why I wanted to go over seasons really fast is because the very most important factor that affects the climate of a region. So why is Michigan's climate the way it is? The number one, the most important factor is latitude. Right. And what latitude is really dealing with are those pesky rays and days. Right. Why is the equator so hot all the time? Well, it has strong rays every single day. Plus, it has 12 hours of day every single day. So it has strong rays and it has long days. So that means it's going to be warm. It's going to have a lot of energy transferred to the surface. The sun's going to heat the Earth's surface well, and then the Earth's surface will heat the air and gets warm. Well, what happens at the North Pole? North Pole has the opposite. It has weak rays, right? Actually, as a point of a fact here, the North Pole actually has 6 months of nighttime. So it has no rays and it has no days for 6 months, right? The other 6 months, it has daytime. But the angle of light that's coming in is so weak. It's basically 24 hours of like a sunrise, sunset kind of thing, where the sun literally will just go around the horizon, go up and down a little bit like a carousel, but it'll never quite dip below the horizon for about 6 months, right? So it never gets warm in the North Pole or the South Pole for that matter, because it has very weak rays and it has very short days, especially in the winter, right, where it has no days. Okay, so here's a document. You guys should print this out if you can. If you can't, take pictures of it, draw what you can, follow along. All right, here's the document. I added a little bit of info. All right, now I'm going to zoom in a bit. All right, so here we go. Look at that hilarious title, Climate, Not Climate. Who thinks of these things? It's hilarious. Anyways, the number one factor, by far, the number one, is latitude, right? You can't change the rays in the days of a location, right? If you're at 20 degrees north latitude, there's not a lot that you can do. It's going to be warm there pretty much all the time. And if you're at 80 degrees latitude, there's not much you can do. It's going to be cold there all the time, right? You can't change the rays in the days. There are some things you can do to make things warmer or colder, but generally speaking, the latitude is the biggest impact. Gets the biggest bang for the buck. Okay, well, Michigan's right in the middle. Like, we are dead center, right? We are 45 degrees-ish north. So we're going to use a whole bunch of different colors to represent different things that we're going to graph. Okay, so these are what we call climate graphs. They're climate graphs. So on a climate graph, you have a lot of information you can see here. All right, we're going to color coordinate. So you got to be coordinated. All right, so we're going to color coordinate, and here's what we're going to use. I'm missing a color, and I'm a little bit there. It is. Okay. Anyway, so we're going to have a bunch of different things on here. All right. First thing we look at here is temperature range. And I'm taking a purple colored pencil, and I'm just going to circle this in purple because I want to know that every time I look on this diagram here, these graphs, whenever I see purple, it's temperature range. Okay. Right. And here's, some fairly obvious statistics. The range in temperature, believe it or not, if you go to the equator, it has like basically no range. Remember, range is change. How much hotter does it get? How much colder does it get from season to season? Well, there are no seasons on the equator. It's the same every day because they have the same rays and days every day. All right. So they don't get a change. And so they got the same hot temperature every day. Well, the North Pole has 6 months of daytime, 6 months of darkness. So it actually has a big change in its temperature. Right. But it never gets warm. Right. It's never warm. It could be warmer than it was. Typically what happens is it goes from cold in the summer to insanely deadly cold in the winter. Okay. That's the range, but it's a huge range. It just happens to be a very cold one. So that's temperature range. Next thing we're going to look at is monthly average temperatures, and we're going to use green for that. All right, so month to month, how warm is it in January, then February, and then there's like other months and stuff. All right, so we're going to use green for that. Rain, we're going to use blue. How much rain does it get? Okay. And then finally, we're going to take all 12 months. We're going to add up the monthly averages, and we're going to determine the annual average. The annual average temperature is going to be in red. Okay. So make that red. So here we go. Here we go. We're going to start with the equator. And I always start with the green, the monthly average temperatures. And I'm going to plot each month, right? You can see them down here, January, February, March, and then they go back to January for some reason. It doesn't really matter. We're going to plot each month, all right? But we're not actually going to plot each month because that would take too much time. So we're going to approximate the temperatures from month to month. So here we go. On the equator, every day, so therefore every month, and so therefore every year, they have a high average temperatures, 80s, 90s. Why? Because the sun's hitting it really strong, raisin days, and it has 12 hours of daytime every day. So I want you to start at this top of this parenthesis right here, and we're basically going to draw a line straight across. Now, normally what we would do in a climate graph is we would plot 12 different points and then connect the dots, right? But we don't need to do that because pretty much every month is the same temperature. So there we go. It just goes straight across. Well, if I add up those 12 months, divide by 12, I find out that the average temperature, annual average, is pretty much on the same green line, right? Because there's no variation on the equator. There's no seasons, right? It's always the same. Hot. What's next day going to be like? Hot. All right. So it has a very high average temperature, and that's what I'm writing in red. It has a high average temperature. Okay. Now, what it doesn't have is change. Every day, every season, month to month, year to year, the same. Okay. And that's where the purple comes in, right? It has no range. Why is there no range? Because there's no change in the raisin days. Every single day is the same on the equator. All right. No range because there's no change. Okay. No range, no change. Woo! All right, so that leaves us with our last piece of data. Now, on a climate graph, you always have two y-axes. You got the temperature on the left, and then you got precipitation on the right. Now, temperature, we always make a line graph, right, like we did there. Precipitation, we do a bar graph, okay? Now, the sun heats the earth, and then the earth heats the air. The equator is warm. What happens to warm air? Warm air rises. And when warm air rises, it makes rain. So what do we get a lot of at the equator? Rain. And that's why we find all the tropical rainforests, right? Think of, obviously, the Amazon, the Congo, think of the Philippines, think of all the different areas where it's warm and gets a lot of rain. It's along the equator, okay? So what I'm going to do here is I'm going to draw 12 blue bar graphs, 12 of them, because folks, there are 12 months. All right. And I'm going to draw them really, really tall, really, really big. All right. And some of you are going to start counting them and they're going to be like, Mr. Bowsy, that's not 12, but it is 12. It's just a metric 12. So it doesn't quite look the same. So anyways, make sure you color it in blue. So you see that every day it gets a lot of rain. Why does it get a lot of rain? Because warm air rises. All right. Now, it doesn't rain all day, every day. It just rains for like a half an hour in the afternoon. Anybody that's ever visited Florida in the summer, especially late summer, typically this happens every day, right? You get a storm in the late afternoon. Sun heats the earth heats the air gets hot, warm air rises. The faster it rises, the more storms we get. So every day there's a storm in Florida, basically. That happens on the equator all year round. Okay, so that's the equator data. All right, it has most of our tropical rainforests. Right, this is what I'm going to write here: tropical rainforest. Okay, not at all lazy on that one. Okay, so let's go ahead and skip to Farmington Hills. Okay, Farmington Hills. We're not really 45 degrees north, but we're pretty close. We're like 42 point something. All right, so here's where we're going to go. We're going to start with green again, like we always do. And in order for us to have roughly the same climograph here, I'm going to be very specific on where I start. So when I start this, I'm actually going to start at the LI, right, in line, right, roughly parallel to that. And then I'm going to go up to the top of the letter C in Celsius there, right? So I'm at the same height over June and July, because June and July are summer temperatures. And then I'm going to end over here at the bar, all right, at the BA in bar, like that. And then I'm going to make a bell curve, all right? We've been seeing a lot of bell curves on the news, all right? We want to flatten the curve, all right? Well, that's what we're looking at here. We're looking at a bell curve. And what you see is that in June and July, Farmington Hills is warmest. And then December, January, we're coldest, right? That's what we're looking at. We're looking at our seasons there. Well, if I add up all 12 months and I divide by 12 and I figure out what the average is, here's what I get. I get a red dashed line roughly right in the middle, okay? Right, so we have a medium average temperature, right? Because we have a medium latitude. Makes sense. All right. So because we have seasons, we get pretty hot in the summer, we get pretty cold in the winter. So we have a decent temperature range, right? We have a medium range. And we have a medium range because we have a medium change in the rays in the days, right? We have 16 hours a day in the summer. We have pretty strong rays, right? And then flip in the winter. But it's not as extreme, right? It's not hot every single day like it is in the equator. Now, go to the North Pole. Let's do the same thing now. Oh, wait. Rain, precipitation, all right? Michigan's in the middle. We don't get a ton of rain. Looks kind of like this. All right. We're definitely no rainforest over the days. So that brings us to the North Pole here. All right, North Pole, we're going to start at the very bottom left, right? We're going to go up to roughly the LI in line. So basically the coldest temperatures in Michigan's winter are the warmest temperatures in the North Pole's summer, okay? And then we're going to end again way over here. We're going to make another bell curve, except this one's not going to be very flat, and this one's going to be bigger, all right? Because it has a much bigger range. Huge range. Why does it have a huge range? Because it has a huge change in the rays in the days, right? 6 months of daytime, 6 months of darkness. You cannot have more change than that, okay? Now, if I add up the 12 months and I divide by 12, I end up with a very low average temperature. Shocking. North Pole has a low average temperature. I know your jaws, probably pick up your jaws. Pick them up. All right. I know they're probably on the floor. Pick them up. Okay. So anyways, it looks like that. Now, for the opposite reason, or actually comparable reason, the equator is hot, so it has warm air, and warm air rises and it makes rain. Well, the North Pole is the opposite. It's cold. Cold air sinks, and because cold air sinks, it actually doesn't make precipitation, right? So actually, the North Pole is technically considered a desert. So I'm going to take my blue, and I'm going to put very, very, very small bar graphs, 12 of them, of course, because I like perfection. But some of you are like, how is there ice at the North Pole if it's a desert? Well, when it does precipitate in the North Pole, just like any desert, eventually there's going to be precipitation. When it does snow in the North Pole, it's so cold in the North Pole, right, that it sticks around. Doesn't melt. It's certainly not going to melt. It's never going to melt in the North Pole as long as its highest temperatures are our lowest temperatures, right? It's never going to happen. So once it falls, it stays solid, and it sticks around for a long time. And that's why nerdy earth scientists like me, we can go to the North Pole. We can drill into the ice, and we can drill so far down into the ice that we literally were going backwards in time when we're studying the ice, right? We can go back to about 500,000-year-old ice at the North Pole and the South Pole. It's pretty cool. All right. So anyways, latitude. I hope you enjoyed this discussion as much as I enjoyed giving it. I hope to see you soon. Take care, folks.